Alright, so today we're going to be talking about sequences, which is really just a fancy way of saying that we're looking for patterns in lists of numbers. So each sequence is going to be a list of different numbers, and I have an example here that starts out with 100. So in this sequence, we start out with 100, then we move to 93, then 86, then 79, and then there's some more numbers that come after that, but we don't know what they are just yet. So before we get into how we can figure out these new numbers at the end of the sequence, let's talk about some vocabulary. The first little star here comes, you can see that it's connected to this 100. I put that bracket. That's what we know how we can talk about each one of these individual numbers. So each one of those numbers in the sequence is called a term. So here I know the first four terms, the 100, the 93, the 86, the 79, these are all terms in my sequence. I'm trying to figure out the next three terms. That's why I have those blanks. So as we're looking at a sequence, really what we're trying to do is figure out the pattern. What did we do to get from the first number to get to the second number? And sometimes you can do more than one thing, so you got to kind of keep your options open. So as I'm looking from 100 to 93, I know that I can subtract 7. So I'm going to keep that in my mind. Let's see if it works for the next one. So now I've got 93. And I know that I wanted to subtract 7 because that was the original rule. Well, 93 minus 7 is 86. So far my rule seems to be working out. When we do 86 minus 7, that's another, it ends up working out. 86 minus 7 is 79. So I think I've gotten my rule here. I got the same rule for each one of these changes. So now I'm going to use that rule. I'm going to use this minus 7 or plus a negative 7, either way, for each one of these. So 79 minus 7 gives me 72. Now for my next term, I'm going to subtract another 7 or add a negative 7. I'm going to get 65. And then I'm going to do it one more time to find out that last mystery. So I'm going to do minus 7 and I get 58. So now that we've completed the sequence, now we can go ahead and keep talking about that vocabulary. So that number, that minus 7, that negative 7 that I was adding every single time, that's what we call the common difference. So go ahead and fill that into your common difference. That's that vocabulary word for that same number that's being added every time. Now, I kept talking about subtracting 7, subtracting 7. That's easier for me to think about in my mind. However, remember, we can add a negative number instead of subtracting. So here, even though I said minus 7, that's the same thing as adding a negative 7 each time. So this is an example of an arithmetic sequence. That's where we add the common difference to find the next term. Now once we know what that rule is, what that common difference is, I can make a variable expression. Remember, variable means that we're going to use letters. So for my letters, I'm going to use an x. And so for every single term, I kept adding a negative 7. Remember, another way I can write that is to do x minus 7. Those are both good expressions, good variable expressions to represent this sequence. Let's try out another one. In this one, I still know the first 4 terms, and I'm looking for the next 3. So before I talk about the vocabulary for this one, let's just try to figure out the rule. Well, I went from 2, and then I got to 6. Well, there's a couple of different ways we can do that. I could multiply by 3, but I could also add 4. Both of those rules would work for those first 2 terms. So let's see which one we use for the next one. Well, now I'm starting at 6, and I'm going to move to 18. Adding 4 no longer works. So I'm going to go ahead and cross that one out. That does not work for every single term, so it cannot be my rule. So that means that my times 3 is probably going to be my rule that I'm going to use. Let's check. 18 times 3, I do get 54. So it looks like I figured out my rule. So let's try to figure out my next couple. I'm going to keep doing that same rule, that multiplying by 3. So 54 times 3 gives me 162. Multiply by 3 again, I get 486. And multiply by 3 one more time, I get 1,458. Now this time, I was multiplying by the same number each time. That's what we call a common ratio. That's that same number that's being multiplied each time. So this is a little bit different from the common difference. Remember, that was when we were subtracting. Now remember, you can multiply by a fraction instead of dividing. So for example, if you were doing divided by 3, that's the same thing as times 1/3. Just a little review on fractions. All right, so this is called a geometric sequence. That's when we are multiplying the common ratio to find the next term. So multiplying goes with geometric, adding goes with arithmetic. So for my variable expression, I am going to start out with x, and I'm going to use that rule. Well, I could write this as x times 3, but now that we're in 7th grade, we more often see it as 3x as our rule there. So I'm going to go ahead and box that one. That's what we usually see. Let's try another one. All right, so for this example, I start out with 15, I went to 16, then 16 to 18, then 18 to 21. So let's try to figure out my rule. Well, from 15 to 16, there's really only one thing I can do there. I can add 1. To get from 16 to 18, I'm not going to add 1. That's actually adding 2. 18 plus 3 equals 21. So it looks like I do have a rule. I'm going up one additional number each time. So here I added 1, I added 2, I added 3, I added 4. So here I'm going to add 5. And then for the last one, I'm going to add 6. So let's figure out those missing terms. Well, I started out with 21, and now I know that my rule was to add 4. Well, 21 plus 4 is 25. 25 plus 5 is 30. And 30 plus 6 is 36. Now this one is a little bit tricky, and that's why I put that big watch out at the top of your notes page for this section. When we look at all these numbers that we were adding, we were not adding or multiplying the same number each time. So that means that this is not arithmetic or geometric. So this is one of those weird ones where there still is a pattern, but it's not the same pattern, so we can't label it as either of those. All right, one last review here. Remember, we can use variable expressions to describe the relationship between two terms in a sequence. So how are they related to each other? Am I adding the same number each time? Am I multiplying the same number each time? Am I multiplying by a fraction instead of dividing? Remember those little tricks. Variable expressions must be true for each term in the sequence. So we have to try out every single term with your rule before you can decide on it as your final answer. So remember, back when we were doing this one here, I saw that plus 4 would work, but I had to try it out for every single one. So I was able to rule this one out because it did not work for the next term. So plus 4 was not a good rule for this geometric sequence. I needed to use the multiplying by 3. So that's just a quick run through of what sequences are. We're going to get a chance to practice finding them, practice finding the rules, practice completing them in class. So make sure that you have your note sheet ready for when we start practicing.